Welcome back to the MLOps Community Podcast. I am your host, Dimitrios, and I'm currently broadcasting from the island of Crete in Greece. Today we talk to none other than the CEO of Tecton, Mike Del Balso. And if you've been following along, while I am here in Greece, I am just pointing out a few Greekisms that I find when I'm here, and it boggles my mind. I don't understand. So if you work with any Greeks, or if you are Greek yourself, I have a few questions for them, because this is the country that invented democracy. Yet they, for some reason, have not figured out how to make pipes that toilet paper can go into. What is that all about? No matter where you go in Greece, you have to throw your toilet paper into the trash. I do not get it. I do not understand it at all. All right. So please, someone who knows about the tubery, or someone that is doing some kind of ML, maybe we could just upgrade the system. We'll just throw some AI at it and it'll be an easy fix. Anyway, didn't come on here to ask questions about Greece. We came on here to talk about feature platforms and everything that comes with it. I have a great time talking to Mike. Always, he is a avid guest and co-host on the show. And so today he was meant to be a co-host, but our guest of the day is a early retired Josh Wills, and he just didn't show up because he apparently doesn't keep a clock in his house. Sorry, Josh, if you're listening to this, I got to go into it a little bit. So Josh was supposed to be our guest. It was meant to be a great conversation between Josh and Mike, and it ended up happening, but it happened at the end of the conversation that I was having with Mike. So Josh showed up 55 minutes late to the podcast, and we ended up talking with him. We extended the podcast to like 30 minutes, and we had a blast having Mike and Josh just pontificate about where the future of feature stores and feature platforms go. But before that, when I was talking with Mike, I was asking him all kinds of questions about what he sees as main barriers to entry and pain points or that a feature platform can solve for. And so he walked us through his history, how he was working at Google and then he was working at Uber, and why he felt like a feature platform was so important, a feature store, which then evolved into a feature platform. And he also talked about operationalizing these data pipelines and feature pipelines, and why that can be hard and why it is so important. Had a great conversation with him. As always, if you enjoyed this, please share it with a friend, because that is how we will grow and continue to get the good word out about MLOps, LLMops. Oh my God, I can't even believe I'm saying that. It's not coming out of my mouth. But last thing is, I want to give a huge shout out to the Tecton team, because they have been supporting the MLOps community from the beginning. If you are on the market for a feature platform, check them out. We'll leave a link in the description, or just hit up Mike directly in Slack and tell him I sent you. So, all right, Mike, we're here today to talk all about feature stores and all about what the hell is going on these days with the feature store, but also to get into a little bit of the features and maybe clear up some questions on what is on everyone's mind when it comes to features and the new paradigm, we could say, of machine learning / AI and LLMs, and how those fit into feature stores, how features and recommendations and all that good stuff can be powered and play together. So I think it's probably good just to if you can give me a bit of an orientation on where we are right now with feature platforms, feature stores, and how it's changed, how it's evolved over the past couple of years, because it is constantly moving, right?
Yeah. Okay. So I think there's two concepts that we chat about sometimes. We talk about feature stores and feature platforms. And I think it's good to talk about the difference between both of those. And then it's good to also understand, maybe useful to talk through the history of kind of how we got to where we are today. But I think what's probably most interesting for the community is like, what do I need and when, and like, when is this relevant for me? I've heard a lot of like awesome companies use this stuff and my company doesn't. So should I be thinking about this kind of thing? So also disclaimer for this whole thing that, we make what we think of as the leading feature platform, which has a feature store. You're getting one side of the discussion from me, but I try to be pretty balanced about it. And so maybe it'll be helpful just to kind of talk through a little bit of like the history first, just to kind of understand some of the motivation. And so I used to work at Google, and and we ran the real-time AI models that choose which ads you see. And you had Sculley on here before, and that guy. So I was his PM. So he was the eng manager. Maybe the smartest person I've ever met. Sculley's really awesome. And
very, very underspoken. And, he would never tell you he's the smartest person in the room, but you can figure it out very quickly.
That guy's the real deal.
He is, for everyone that is wondering, he wrote the 2 seminal posts on machine learning back in like 2017.
No, even they wrote the the paper, Machine Learning the High Interest Credit Card of Technical Debt, in like 2013. That's when I was on his team, but like I was junior mode, and so they didn't even tell me they were writing a paper. So I wasn't in the driver's seat on the team at that time, but these guys had been solving these problems for a long time, like true deep MLOps problems. So to give everybody a sense of the kinds of problems that Google was solving at that time, so 2013, so 10 years ago. So MLOps and LLM stuff feels like this whole new thing, and certainly LLM stuff is. But Google 10 years ago, this was probably what I still think of as like the most productionized ML application, the best productionized ML application in the world at that time. And it was a gigantic logistic regression model. Like they had their own way to build this gigantic thing, and it would be live training and updating every 15 minutes on all the searches in the world. And they had like thousands of features in these models, constantly being computed in real time and being driven and into the ads models. But these features were sourced from all kinds of different data sources too. So think of like, you're a user of Google. So maybe they have some microservice that prepares some user preferences for Demetrios. And then they have another thing, which is like calculate some statistics for each merchant or each domain or something like that. And then there's a lot of like complicated ad specific stuff. So the point was, this was like this behemoth system constantly running, launching new models on the fly. And so they were really far advanced in the ML. They were like at the MLOps dream state where everything is live learning and happening automatically, and they're tuning the system at a high level. So they were trying to solve problems like, here's 2 example problems. One is when we roll out a new model, then that is going to start making different predictions than the old model. But that means if you're getting different predictions in real time, that means you're going to show different ads. And so when you show different ads, then, because of what's happening in real time becomes your training data changes. And so how you were building training data 10 minutes ago compared to how you're building training data now is going to change. But we didn't build this model on the new training data. We built it on the old training data. And so are we going to introduce some weird feedback loop and things are going to go wacky, and how do we control that? It's a problem that like probably nobody in MLOps community has even thought of. But like, when you solve all the other MLOps problems, then you get to that kind of level. And it was just really, and that's like, Sculley's the guy behind that, and did a lot more there. And and then they replaced it all with deep learning. And so real-time learning, deep learning model, fine-tuning, stuff like that. But the real thing that I learned, so anyway, all of that context to say that one of the interesting things that I learned there was that so much of the ability to build this high quality AI system, this really deeply productionized AI system, was that their ability was completely based on their data capabilities under the hood. They had so many high quality data sets. They had so many great tools to access and develop and test with these data sets. And that allowed them to be efficient in building high quality models and systems, and build those systems that create those high quality models and roll them out and maintain them in production and stuff like that. And probably, the one of the most important of such systems was all of the feature infrastructure, the stuff that's constantly computing and serving the new signals. So that was a lesson to me that, hey, this stuff is very important, even for super advanced use cases.
Yeah.
And even after you go into the deep learning world, there's this kind of whole data supply chain kind of issue. You need to pass all the right data and the right context along to the model such that it can make the right decision. And it's not something you learn when you go to machine learning class. You don't learn like all of that, the whole data supply chain component of it. And it's also, these problems are not something you learn when you go to analytics class. When you go to, to become a data scientist, they teach you how to use R, how to use Python, make some plots, make a dashboard, stuff like that. But it's not the same kind of stuff as the production data engineering that happens at scale and sometimes in real time to power production AI application. So very hard domain. Then I joined Uber, and at Uber, we were starting from zero. Basically, it was, so I joined Uber to like start the ML team there, start the ML infrastructure team, and really like enable ML across the company. And when we did that, there was like nothing. There was no infrastructure there. And so we had to, build the model training, the model serving, all of the parts of the ML platform. And that system became called Michelangelo. But one of the most important parts of that system was exactly that same thing, the feature infrastructure, the parts that allowed the data scientists in the company to access all of the data in the business and build models, build decision-making systems on top of that data in a way that wasn't going to be impossible to productionize. So it's not that hard to go and just download some data and then do a bunch of stuff in a kind of like in your notebook and like some kind of unreproducible processes that you forgot what they were, but you kind of molded a training data set and you built a model and then you forgot everything and you lost all of that code or it's all a jumbled mess, but at least you got the model. The real task for these teams that are building AI applications that are kind of like operationalized and productionized, like AI teams that are really focused on the true finish line for value in ML, which is this thing is operating in production and delivering value to the business, not just delivering insights internally to help me with the decision, but it's delivering external insights to my customer or external decisions that affect the product that my customer interacts with. That means they have to get to the production. Then that's the important finish line. And for them to be able to do that, they need to be able to build these models in ways that can be easily productionized. And that requires that productionization step means you also need the data to be productionized. You also need the kind of data supply chain to be operational, not just like a one-time hacky code thing that you built when you were building your prototype. And so we kind of already thought about that, and I had been exposed to a lot of amazing designs and amazing solutions for that kind of thing at Google, and so that influenced a lot of our designs for building the feature infrastructure that was part of Michelangelo. And the whole purpose of that was to make it really easy. The way, if you kind of like instantiate that and drill it down to something very specific, make it very easy for people to access business data, turn it into features, store those features, and serve those features in production and generate models with those features. So generate historical training data sets and do real-time serving with those features. So that's a little bit of like the genesis of Feature Store. And that's when we came up with the term feature store, and we started calling it Feature Store. We started talking about it a little bit, did some blog posts about Michelangelo.
You got your name on that blog post, though. That paper you did your name on.
Yes, exactly. Yeah, I did write that blog post. That one I was involved in. And
which is another seminal one. I mean, to be honest, that's one of the ones I think a lot of people were looking to Uber as far as like, what are they doing? And when that came out, it was huge for everyone because they got to see like, okay, this is how you guys are viewing it. And this seems very advanced compared to me and my Jupyter Notebook.
Yeah. And honestly, I've been like humbled by the number of people who said, oh yeah, we just read that blog and just tried to rebuild that exact thing. Because it's honestly not a bad plan, especially like a couple of years ago. Like when we did it at Uber, there was not even tools you could buy that would do this stuff. But when we did the blog post, we had a lot of people reach out to us and they were saying like, hey, I'm trying to solve the same problems. Can you either like, hey, can you come work at my company, or can you open source this thing? Can we work together? Kind of thing.
And that's when you knew. You were like, nope, I'm going to start a company.
Well, yeah, actually, I was like, oh, okay, this is a problem. This is not just, I saw it at Google, saw it at Uber. It's, some advanced companies are dealing with this now, but if you talk to every company, they want to do production machine learning. And so, this is an important thing for, for the industry in the future. It's an important problem to solve. And so we built, so basically myself, my eng lead at Uber, we left and started Tecton. And so what we've done at Tecton, the quick pitch for Tecton is just the feature platform that you would have at a Google or a Facebook or an Uber kind of thing. That's what we make available to you, so you don't have to build it. And you don't have to spend hundreds of engineers doing that. And that means you get to build better features, and that means better models. You get to do it much faster, and you get to do it with fewer people. So the same people you have can work on doing more ML and stuff like that. So that's, I'll kind of constrain the Tecton pitch to just that, but that's like the kind of outcomes that we try to drive. And so over the past, handful of years, we've seen, just to finish up the history thing, which is kind of, I appreciate is now going too long, but we've seen it go from, like this mode where people were like, hey, I've never heard of this feature store thing. I don't know if I'm ever going to have this problem, to, oh yeah, I've heard of feature store, got a couple questions, I'm not too sure, to now people are like, hey, I've got like 2 feature stores I've built before. We hate building a feature store. It's a pain in the ass for us. And we want to buy like a more comprehensive feature platform. Here's our specific requirements, and can we try out Tecton kind of thing. So the industry has very much matured, and I think that's there's 2 reasons for that. One, because we've kind of like helped inform people about, hey, there's solutions to these problems. But second, just because people have, they've gone through the stages of MLOps maturity. And, the first thing you do is just like, can I build like a very simple model in my Jupyter notebook? But then you get to this point where you're like, hey, I'm trying to productionize this stuff and do it efficiently and reliably and keep it accurate and stuff like that. And there's problems that you only encounter when you're at that stage. And a lot more people are getting to that stage. And that's when, a feature platform becomes super, super useful.
Dude, so true. And I love a few things that I'm just going to like try and talk about from your summary. One is the operationalizing of the data, and that data pipeline needs to be on point. And how many people have felt the pains of that when it's not? That used to be, I think, 1 out of every 3 posts in the MLOps community. Something like, hey, so my data scientist kind of fucked things up. How do I get out of this mess? And that's like the main thing that we're seeing. And now I do appreciate too that a lot more education has gone out there, so people understand the ways to do it. Whether or not they follow along on these different practices is their choice, but at least people understand that, whoa, there's a better way. And look, here they can reference different blog posts, and they can see that there are different tools out there, and so they can understand it better. And then the last thing that I was going to say is that just I'll sing your praises on Tecton too, when you were talking about how you went and you did it. And I think it's almost in a way better because you're 100% focusing on feature platforms. You're not focusing on the whole thing like you were doing with Michelangelo. You're just saying, hey, there's this really important slice that we saw was so difficult to get right, and we're going to just focus on that 100% and make sure that we can do that right. So I do respect that you went about it that way.
Yeah, thank you. And I do think we're very much specialists there. Like, I think, like, the thing I like to say when companies come to us and they say, hey, we have this like wacky problem, because people's problems are all different, but so I have this weird data source you never heard of before, or we got this nuance in how we calculate our features and stuff like that.
We get data from the NSA. We can't tell anybody.
Exactly. But the secret. We can't tell you what we do, but we need you to solve the problem. And but what I say is, there's not another team in the world that thinks about this problem more than we do. So come chat with us, and it's not going to be like if you talk to AWS and you talk to a sales guy, and it's like the side thing of the 1% of his time, of his training class time thing. This is all we do every day, and we know all the nuances of what all the teams have done. So anyway, so we're specialists, we focus on it, and that allows us to have like that's our strategy to have a better solution here all around operationalizing the data for ML.
Yeah, and I think there was another thing that I wanted to ask about when it comes to this operationalizing. How have you seen people go from either 0 to 1 and how that looks compared to the 1 to N?
Yeah. So good question. So we kind of help with both stages, and we have customers who are going through both stages of that, like going through that journey, both stages of that journey. And when you're, okay, so let's talk about stage 0. Stage 0 is you have a prototype, but you don't have anything in production. You just never had anything in production at all. And maybe you're, and you can break this problem into a few different ways, but one is you're trying to productionize something and generate automated predictions, regular predictions with it. And so folks need just a way to standardize, hey, this is my pipeline that runs. Maybe my organization has a number of models and they want to reuse different parts of the pipeline. So I have the one feature that's used across multiple models. And then I have my model, and there's this notion of productionizing it. And so sometimes the productionization means I'm doing predictions in real time. So a lot of our use cases are someone's logging in and we want to determine, is this actually the real person? Is it fraud or not? Or someone's loads the website and we have to make a bunch of recommendations. We have to compute some recommendations to show them. Or we want to do some personalization thing. And that all happens, in the moment, like the user's logging in. So you need to be fast, low latency. And that's kind of just like the basic set of things, is the core things: connecting to the data, computing features, storing them, and serving them and retrieving them in real time, and retrieving them offline in production, or offline for model training. And a lot of companies are in this stage, or they're going through this journey, but there's kind of there's a difference between going from, or there's like two dimensions here. There's not just like going from 0 to that point, but there's also, like, I think of it as an orthogonal dimension of getting to that point, but being able to do it like repeatedly across many teams in your company, kind of like the enterprise thing. So we have a lot of like Fortune companies, customers, who they're not doing anything more advanced than that. They're not doing like real-time streaming, real-time calculation stuff, super optimized performance or whatever, but they're just like, look, we just have these features and they need to be reusable across 100 teams, and they need lineage and they need monitoring, all plugged into this stuff, and they need to be able to retrieve it online. So that's like the very proto feature store, the basics. And then it kind of branches off from there. So what I meant by like everybody has different problems, so it's kind of stage 2 of sophistication. There's a lot of different kind of ways that things get more advanced, or rather you can think of it as like people's requirements get more intense. But not everybody, it's not just like everybody has the same thing. So some people, so I'll just talk through some examples of requirements that many use cases have. And maybe if you're listening to this, you're going to be like, yeah, I have number 2 and number 3, but I don't have 1, 4, and 5. But some things are like, I got to plug into a stream of events, and I want to turn that into a feature and have that updated really quickly. So I want to continuously calculate some features on a stream. Another one is, I have, this user is logging in and I've got some information from them that I only get in real time. I can't pre-compute these features. So these are coming in at inference time. Imagine I'm signing up for insurance and I'm typing in, all of my details into the web form, and I press submit. So I need to calculate that stuff in real time. And so that's another set of requirements. We have a lot of customers who are kind of like large tech companies that have, or basically like B2C, like consumer software companies that have huge scale. So this scale thing is really interesting too. Like, how do you get all this data, but how do you serve this data fast enough and in a cost efficient way at gigantic scale? So there's a lot of the problems that we solve are around doing all of these data pipelines that I just mentioned, doing them in a very cost efficient way, so you're not wasting a bunch of money. And so it actually scales the cost you have per prediction effectively, makes sense for you, because we have a lot of customers who are just like, hey, we're trying to add these signals to our models. We're trying to build these pipelines. We're trying to build this stuff, but it just ends up like literally costing more than that getting a good prediction is even worth for us. And so there's a lot of opportunities, and these are repeated problems, to build in such optimizations into a feature platform to have the right cost optimizations on the information retrieval side, the serving side, with the right types of caching and the right types of using certain integrations between the data pipelines and the online stores to efficiently load them up into the online stores and stuff like that, to allow for like a more cost efficient solution there. So those are kind of like a couple of the other domains that are areas where we see people like push the limits. Another is, hey, my feature, I need you to go call out to another system, like to a system that provides credit scores or something in real time, get that score, do something with it, and pass it along. And then of course there's LLM stuff that we can talk about too. But so the point is, there's the kind of the basic mode, and then if you kind of go to anything that's like a little bit, once you get there, you're like, okay, I want to do something better. And then there's a variety of different ways you can go a little bit more advanced. And if you go to the feature platform, the feature infrastructure they have at Meta, Google, stuff like that, they've got an awesome solution for all of that. And that's how they power the news feed and the ad system and search and all of that. And, that's what we're building to make it really easy for anybody to adopt that. Because these problems, especially as soon as you get past that basic mode, which is by itself not super easy, but you get past that, those have become really hard data engineering problems. And we see when people are kind of like, a lot of our customers, when they become our customers, they're not at stage 0, they're at stage 1. They're like, hey, I've kind of got this basic thing in place, and now, it was like easy for me to get here, and then the difficulty for me to get to the next stage is like way higher, and now I need help.
They're starting to scope their work, and they're like, ooh, this is going to take a few sprints. I didn't realize what I was getting myself into.
Yeah.
And it's funny you say that, because in one of our pancake stack sessions where we basically break down what everyone's stacks are, and one person will present, and it's all off camera and off, no recording. So it's kind of like a nice little intimate thing, I could say. I don't want to blow up the spot of the person who was saying this, but you know them, and I can tell you after we hit top recording of who they are. They were talking about how much of their effort of trying to build a feature store was death by 1,000 cuts. And it really felt like it wasn't like there was this one really hard problem that they had to sink millions of hours into. It was just like, as soon as they took one step forward, they were getting bombarded by all kinds of different things. And then they put out all these fires, and the next time they took another step forward, boom, there was 20 other things they had to focus on.
Yeah, and I think, so I totally agree. And so one thing to share there is, so some of our customers are like really advanced tech companies that everybody knows, that are like some of the biggest scale tech companies. And they have multiple feature platforms, feature stores, different systems to power their features internally. And they're at this point where they've been like, okay, like, we're not going to keep building this stuff. It's just constantly, no one's ever happy with the solutions we build internally. The maintenance cost is so high for it. And it'll take us so much time to build, to the next stage. And what are we going to do? Hire like a huge team to do that? So the point is, it's gotten to the point where the requirements, like what people are trying to do with ML, has gotten to a level where they need a really good system. And then the options, the commercial options, are also there. So the kind of build versus buy calculus has really shifted in a big way in the past couple of years, and this is where I was saying earlier, Michelangelo, yeah, it made sense for us to build everything, because like the only company that was around was like Data Robot at the time. And also like Uber didn't have any like buying software bone in its body at the time. So it wasn't really a question for us, but I still would have built stuff at that time. Today, I definitely wouldn't. Just the other kind of anecdote I'll say to back you up on that is, I talked to a lot of companies. I talked to a lot of platform teams. So the ML platform teams, where I just remember this one conversation with the ML platform lead. And he goes, look, we have 3 models running on our platform. We're supposed to get to 30 by the end of the year, but I'm afraid to take on number 4, because it's just going to be like such another burden for us. And the kind of like point there that he was saying is his people, the platform team doesn't have the leverage to scale with the business, to scale with the customer demand, because they're doing so much manual stuff on a per, customer basis. So they would have to grow their platform team proportionally. But a lot of people who run platform teams are in this position where they're not going to get 10x headcount. You're not even going to get one head this year. So what can you do to get more value and enable and get more leverage from the few people you do have? And so we can talk a little bit about how we do that, but that's a really big focus. That's like a lot of our conversations.
Dude, it goes back to that Z-axis you were talking about, how there's not only going forward, but it is looking at it in this way of, okay, if I'm going to do this, how can I make sure that I can do this repeatedly?
Yep. And people care a lot about, we talk about getting accuracy, getting reliability in your production system, and then getting repeatability in your ML workflows.
So you mentioned that there was like multiple feature platforms that some of these companies you talk to have. What does that even look like? That sounds like such a nuisance. And it also sounds like, how did someone let it get to that point? But what does it look like in practice when you see that?
So we're kind of now at a point in the Tecton journey where we've really deeply understood a lot of what these big companies have done in their multi-year history. And here's my best understanding of it. And I'll tell you like the story. And then, if you're going through this story, if you're listening, going through this story, maybe you can have the foresight to like kind of connect to some stage of the story and be like, oh, that's kind of where I am. Maybe let me try to avoid making certain mistakes.
Yeah. Hit the parachute now.
Yeah. So I think like the first thing that happens is like, how does a platform team happen? Because we always try to talk to platform teams, but like, what is a platform team? And so the way I see platform teams evolve, I kind of think about it like in biology, there's like a cell and you have meiosis and like split into two.
No, I will not recommend your podcast. As the ML lead engineer at DQB Bank, I'm definitely not wanting other engineers to have all this relevant information, and I will not give my name, which is Lena. So definitely, I do not recommend this podcast.
So what happens is, you start with like one data scientist, and they're building the model. And then it's like, oh, this is like the early stages of your company or your business unit or whatever. And then it's like, oh, okay, actually, there's something here. We should invest in this machine learning thing. And okay, it needs some engineering. So still on the same team, there's two people. And then it kind of grows. And then, okay, well, these people are going to kind of like focus on building the production side of it. These people are going to focus on the modeling side of it. And then you have maybe the modeling people start focusing on two problems. And so then you have the modeling and the production people, and then let's make the production people like an infrastructure team. And so, or a platform team, and it's some, Fortune companies is kind of like IT. So it splits off. And then that infrastructure team might be like imagine all these problems are like fraud that we were talking about. It's within the business unit. But then you have a personalization business unit, and you have your payments business unit or whatever across multiple business units, and they go through the same thing, right? And so they have these platform teams. And then these like business unit specific platform teams go like, hey, we're all building, a training platform. We're all building basic data pipelining for ML models. Let's have kind of like a central team, and sometimes call it a center of excellence too. And so those infrastructure groups pull out, and you have multiple layers of platform team, and then you get to, and so it's just kind of like different layers of specialization. And this is not bad. I'm just saying like how it goes. And so, so that now to turn to how like feature infrastructure kind of gets to a messy state, and there's probably a very similar thing with data infrastructure as well. But what happens with feature infrastructure is, that first team, that fraud infrastructure, ML infrastructure team, they're like, oh, we got this like specialized feature nobody else has. We got to process things in real time. So they build a little like thing that runs Python in real time. And then, just like their little fraud modelers use it in production. And then you have like the personalization people, like 6 months later say, hey, I want to do real-time features too. instead of me building this thing, let me just use the fraud guys thing. And so then the fraud guys thing was never designed for, being a really nice like horizontal system. It was just, the one engineer who built it in some hacky way using some weird programming language maybe. And so then maybe they start depending on that other business unit, or it gets kind of pulled out here. But that process kind of happens in parallel for different types of requirements. So you end up, I'm thinking of a big payments company. They have one kind of feature processing infrastructure that's like for the streaming stuff that everybody hates now because it's like old and it was built for like this one team, and they have to do all this weird munging their data in a weird way, and all their modelers have to learn this weird system to be able to create features for their thing. And then there's another one for real-time features. Then there's another one for features that get pulled from Snowflake. And then there's another one for features that are processed using their data lake. And so there's just this big like kind of constellation of like different tooling that don't work well together. And so when you look at it as a whole, you didn't really solve the problem of like building a training data set and serving simply in production. You just kind of changed the problem from a bunch of disparate data sources to a bunch of disparate chunks of feature infrastructure. And when they get to that point, they're like, okay, like we could either do this thing where we take on a huge multi-year project to rebuild all of these things in one thing, or we can just, consider buying it.
Yeah.
So if you're kind of going through that, or you're seeing the early stages of that, at least come chat with us.
Yeah. I think a few people that are listening are probably getting PTSD after you explaining that, because I know certain people, engineers, who have left their jobs because it's just like, ooh, this has gotten to be too much, and leadership doesn't understand the value of us spending the time to go and make this right. They're just like, it's working, right? Let's just keep going.
Yeah. And I found, interestingly, when we were starting Tecton, I spent some time talking to data scientists at a bunch of insurance companies. And this one insurance company told me that 11 out of 12 of their core data scientists left in the past year. And all of them cited poor data science infrastructure at the time. It was a couple years ago, but like, that's how much this stuff matters. It's not like a side thing for people, and it really affects people's productivity. So anyway, if you're listening to this, you're probably, preaching to the choir. You want to have good tools so you can build stuff, go fast kind of thing. And that's the point here.
Exactly. So, dude, I want to get into this online, offline stuff and the play between the two. And what are the most common choices here? Because I understand it as this, that the online stuff, the very low latency that you need are things like fraud that you're mentioning. I mean, I guess loan scoring, or maybe not. Then you have recommender systems like, gotta know what's on my Netflix page or my YouTube page or like my TikTok for you. And then I imagine there's a few very clear use cases for this low latency, like real-time stuff. And I'm talking real time, because when we get on here, some people say real time and they're like, yeah, like every 5 minutes. And that's not the real time that we're talking about. What is the real time that you talk about? And what are those use cases? And then what are these offline store use cases?
Yeah. Okay. So I think like so your question is kind of like, hey, when you say real time, what do you mean by real time? And what fits into that like band of use cases? And so you can think of it as like from a spectrum of like, don't need real time at all. I make one prediction per year and don't care about real time at all.
And I feel like those are the ones where it's like in organic biology or stuff like that, where you're just exploring different protein folds or whatever.
Well, okay, so let's actually make it even further distinction then. So I think there's analytical. I break it into like analytical machine learning or analytical AI, where you're doing exploration. You're not really productionizing and putting a thing on a schedule. You're not building a system that will live without you being there that day. And then there's operational ML. And so operational ML, the way I think about it is like, it's something where it's productionized. It's like, it's running, you're sick that day, it's still going to run. Right. And so an example of the analytical one is, okay, we're doing like drug discovery or something. Let's write this new script. Let's press run, see what comes out at the other end. Or let's analyze finances for our company and run it and see what happens, right? And that's okay, because if it fails, you just press retry and you're right there. And that's great. And there's a lot of tools specifically for that. But when you're building like a product that is powered by AI, powered by machine learning, you don't want, and it's an important business process, you don't like, if you're writing down your business process, there's not like, and then you ask the guy to go run the script. You have it all kind of like productionized in some way. And so there's a spectrum though of needs with respect to speed. So you can go from there's, on one end is, hey, this thing runs once a year. So I'll give you a good example of one of our customers for that. They compute a bunch of predictions they're an insurance company. They renew their users, their customers once per year, their policies. And so they have a big batch job they run for, however many millions of people at that point of the year, right? And they want to make sure it works at that point in the year, but they don't care what happens in other days. They kind of do, because they do like 1/300th of people every single day, because it's evenly split out, but it's a batch job, and if it goes slow, it doesn't really matter. On the other side of things, the real-time side, think of like, well, actually, let's get there. So then another kind of stage is like a workflow where you do an action and you have to kick off something. Imagine I created an account in your company and you want a whole business process to get started. We're going to, apply for a mortgage for you, and it's not going to happen. You get an instant response, but kicks off a process, talks to this other company, whatever. It can take 5 minutes, maybe it'll take an hour, but it's kind of an asynchronous process. And then another one is one where you are making a prediction. Someone's logging in, and you want to show them some recommendations. So this is even more real time. You want to show them some recommendations, or let's say it's a purchase. You want to score a purchase and say, hey, is this fraud or not fraud? But maybe there's not a lot of signals that you get in real time, but you have a whole bunch of recent historical data. So you've gotten these streams of like, hey, how many purchases has this guy made in the last 5 minutes, right? Yeah. So maybe you're always computing that count for the last 5 minutes. And when they're logging in, you're not computing that live, but maybe you're serving that value. And so it's not super, super real time. It's near real time. That's how we talk about it. And then all the way to the most real time is, imagine I'm Visa or something, swipe the credit card. I need to know like, where is the merchant? How much is the purchase? I got to featureize that all in real time. It has to happen in less than 50 milliseconds so I can generate a prediction and get back to you. And so that's like super real time. And so you can imagine, we can take like any use case, and you can, at home think of like, hey, like what is the use case that I have for my ML problem? And like, which bucket does it fit into? And sometimes there's not just one bucket. Sometimes a bucket, like, you start your problem here, but maybe it's a fraud problem. And you're like, you know what? My fraud model would be better if I moved it over here to make it more real time, because I could incorporate better signals and be more accurate and stuff. It's just a kind of natural journey. But the interesting thing about like this spectrum of going from this batch to super real time, and you can think of it as like different speeds of decisions and different requirements and different speeds of decisions.
Like that.
Is that there's sometimes different under the hood, data processes that power them. And you can take two approaches, right? You can take two approaches to solve those needs. So you can take an approach where you go, okay, I'm going to do like one system. I'm going to build one system. I'm going to use just my data warehouse just for my batch stuff. And then I'm going to like do some really custom thing for my super real time thing. And then I'm going to have another system here. And that's kind of how you get the like patchwork of different systems. And the challenge is, okay, now you have a number of things to maintain. But secondly, it makes it really hard for your use case to upgrade in the journey. So you went from stage 2 and you built it on your system that doesn't talk to streaming systems. Now you want to start using streaming. Okay, you got to like integrate with a whole new system. Maybe it doesn't talk to all the stack you were already using. It's a gigantic project. So a lot of companies that we talk to, they say, look, we actually don't do a ton of real-time stuff right now, but we want to. It's actually competitive. It's like our industry is going more real time. And that's a competitive dynamic for us. For example, like loan decisioning, it used to be, okay, I apply for a loan, get back to me and tell me if I'm approved, or apply for insurance and they'll come back to me with a quote the next day. And then when your competitor goes, oh, cool, like instant loan approval, then you've got some pressure to compete with them and go more real time. So a lot of use cases start at some point in that spectrum. They're trying to go 1 or 2 stages more real time. And so when those companies come to us, they say, look, we've got a lot of use cases that are here or here or here, but we want to move them that way. So we want to be able to support what we can do today and then enable a migration to more real time. And the kind of like the approach that we take is we provide one platform that really like solves all of that. It's really trying to be best in class solution for, doesn't matter where you are in the super batch to super real time perspective, best in class in terms of like cost optimization, scale, best practices built in, and shareability of signals across the whole spectrum. So people say, okay, cool, I'm over here, but I know if I use this as my centralized platform, it's gonna be trivial for me to build these other things in the future. Does that make sense?
For sure. And I can totally see this idea of, we want to get to real time, but considering the way that we built things out right now, in order for us to bring on that capability, it's going to be, again, it's a whole nother undertaking because our offline store is not able to talk with the online store and we can't connect those two. It's like there's just a gigantic wall there and we can't figure out a way to hop over that wall or break through it.
Yeah, and that's a thing that should just be, it's a thing that should be a problem or a requirement that's automated. There's best practices around it. You don't have to solve that. There's now a solved problem. There's really easy ways to do it, and it's hidden behind the scenes with the right platform. Hey, Josh is here.
Hey, there's Josh. What's up, dude?
Sorry I'm late. Hey, Mike, it's good to see you in virtual life as opposed to real life with our kids in the park, basically.
Yeah. How's everything, Josh?
Everything is great, man. Unemployment continues to be awesome. Thanks for asking. Yes.
Love it.
Yeah.
I one day aspire to be unemployed.
I know, man. You're lucky. You figured it out.
I'm a lucky idiot, but I talk to all my portfolio companies and they're all like, I tell like, so like, what is your life like? Well, I play enormous quantities of Pokemon Go and I research World War II. It's a very slippery slope, guys, from like Rick Atkins books to like, I really need to plan a trip to Normandy and do some primary document research.
Yeah.
So I mean, Demetrius, I think like, my two main themes for this, the call here is like, I'm curious about kind of where feature stores are going to go. Like feature stores now is like, feature definitions and then, orchestration and kind of like coordinating the workflow across the offline and the online data stores and stuff like that.
Yep.
I would love to see a feature store dedicated query serving engine that is like a thing that integrates the workflow together. And I know we don't do this today for various reasons. The data's here, the data's there. We need to work with the data where it lies. But I am excited for an Apache Iceberg centric future where, and again, biased that I'm a Tabular investor and Tabular announced a fundraise today, where this stuff is open. The storage format is open to everybody and you can bring the right query engine for the job. And I'm just like, I really want that to happen. And I want to understand, is that on the roadmap? What are the impediments to making that happen? Like that's kind of my first big thrust here. Yeah,
for sure. I think, well, first thing to say is like, I agree with you on that. So talking about like where things are going, just a quick kind of like terminology thing. So we think of like feature store as the system that literally like stores your data in offline and will put it into an online store. And we talk about feature platform as the kind of full set of workflows and that like enterprise sharing and monitoring and stuff like that. And the part of the system, your feature infrastructure that's doing the regular feature computation. So the ongoing raw data to fresh features and often some kind of like optimized serving systems too. For example, in Tecton, we have a whole bunch of like specialized caching stuff that makes, that can help map to your proper use case. And so I think your question was like, hey, I'll try to rephrase and tell me if I'm like getting it right, but it sounds like you're saying like, okay, why do I care about like having all my data? Why would I put my data in this one system that kind of like locks it into this one system? Whereas, why not just have it? Why not have the kind of this open type of system where it's again, almost like a data lake centric version of a feature store where you have feature processing workflows, like all the stuff I just mentioned, but they contribute to feature, and then my feature data kind of just gets stored in some central location that maybe is shared with some other data that can be retrieved for other purposes, maybe even for analytics, or it can be similarly retrieved by different systems for different ML use cases. Is that kind of like the main gist of it?
So I guess I would go beyond in a couple of ways, I think,
Okay.
for what it's worth, right? So for instance, I love DoorDash's blog posts about the various ways they have hacked Redis, and I got to assume Tecton has done similar things. Like you adapt.
We hired
right?
the guy who wrote that blog post.
Oh, that was great. That's like
He's
so
at
good.
Tecton.
So sorry again. I did not. That was an unintentional plug for Tecton. Sorry about that. But that's a fantastic blog post, right?
Yeah.
And I guess what I mean is like, is there a point at which we want to go beyond either hacking Redis keys and structures and stuff like that, or hacking the point in time join queries in the offline Snowflake or Spark based feature store to an actual dedicated query engine, something that is designed from the ground up for the online serving to do the ingestion quickly from the bash offline system, and also like a dedicated query engine for the point in time joins. I don't need to like hack it on top of SQL or Spark or whatever. I can just literally like this engine does it and it's optimized to do that. Anyway, that's kind of what I'm going for. It's like, anyway, it's yeah.
I think you're saying, hey, here's another way to I'm interpreting it. Like feature platform stuff is a lot of platform stuff. It's coordinating other important data infrastructure.
Yes.
But
yes.
Is there going to be feature platform specific data infrastructure, for example, a special serving layer or a special, point in time joining system or feature retrieval engine that will emerge for supporting this, for making these use cases better?
That is I'm hoping basically to lead a product announcement that you're about to do here on the podcast. You're saying, well, yes, Josh. As a matter of fact, we are. Kidding. You don't have to do that. But that's
So
as it happens,
I think the answer is yes and no on the So on the real time on the online store side, certainly. And so we do feel like a lot of the online infrastructure, basically, caching tools and the real time databases, they're not really optimized for the use case that a lot of our customers have. But a lot of times they're close enough. So what happens today is that doesn't become the actual bottleneck for people like making progress in their ML projects. However, we do see, and our plans are to build a proper serving layer, like a specific key value store tuned to this use case in the future.
Yep.
But that's not a like next 6 months kind of thing.
Got it.
On the feature, on the offline retrieval side, we've been going more in the direction of managing and storing the data with a data model such that it's easier for different, kind of like the kind of open model you're referring to, where we store data in a Delta Live table, a Delta table, or a Iceberg table, and we want to provide a lot of different ways for you to interact with that system with those data to process them with the right joins. So we're kind of moving away from the use Tecton specific SDK to pull this data, and we want to make it easier for you to use the tools that you have today to pull and join that data, to kind of get more towards the vision of this feature. There's nothing special about this feature data. You just need to, we're going to do the pre-processing to get it into feature data format. And we do a lot of like intermediate data values and stuff like that, but then we do a lot to like just provide like a polished, published, finalized values, and then you can interact with that. Maybe we'll give you a little bit of a library or something to do the joins, but the join stuff is not super hard in like most engines can do it, except for if you're doing like super gigantic, like you have like you're hitting performance limits. And then we've kind of done some special stuff with Spark there, and maybe there's a thing we can do in the future to optimize, but that's not the goal today.
I gotcha. That makes sense. I love it.
Wait, Mike, you mentioned how that specific thing isn't the bottleneck.
Right.
What do you feel like is the bottleneck that you hit up against much more than that?
I think a lot of people are just trying to get their system up and running in the first place. So it's pretty uncommon that so there's a lot of like setup and a lot of like hey, this thing needs to be able to integrate with all of my data sources, because it's ultimately connecting to my complete data ecosystem, integrating that data such that it can deliver this data to my model. And there's always some snags there. And so we're trying to get that to be faster. What we're trying to optimize is you decide, hey, I need to use a feature platform from that date. How many days until you have a model running in production at the scale and speed that you want? And so that's kind of like, there's a variety of integration challenges that we think we can speed up. And then as just mentioned, a second one is just like, sometimes you have features that you're trying to express that are in your mind. Wouldn't it be cool? I think this would be a predictive thing for my fraud problem if I could do this. And we're trying to continually extend the flexibility of our system to be able to support additional types of feature transformations. That is, that tends to be like more of a bottleneck than kind of like the online performance. Because for us anyway, I think online performance is a bottleneck if you were to use a lot of other systems, even if you were to use Feast. But if you use Tecton, we've put a lot into all of the optimizations for the online system, such that it we're confident we could go, DoorDash is not our customer, but I'm confident we could just plug into DoorDash and, potentially outperform their custom solution that they put together.
There is something, Josh, you mentioned wanting to talk about LLMs and feature stores. And I think we cannot, we would be remiss to not talk about that, especially as you were saying, where are feature stores going? How are you seeing them being used now? And so with that, Josh, I'll let you lead into this next question and where you want to take it.
Yeah. I mean, Mike, this would just be a huge thing. So I'll try to be as parsimonious as I can here. Right. But I guess first and foremost, in the context of deploying a large language model or a system that integrates a large language model, what is the feature? What is a feature in that context? Is it the embeddings? Is it the prompt? How do I think about that? What's my mental model here?
Yeah, good question. So obviously we've been thinking a lot about this, and I think we've talked to a lot of people building LLM applications, and a lot of people are using Tecton to do that now. And we have a blog post with LangChain people that kind of shows the minimal example for this, but I think the key kind of intuition here is, forget about LLMs for a second. What does the feature infrastructure do? What's its relationship with the decisioning system, the model? It's providing real-time context to that model. So it's saying, we went and interacted with the whole world, and we've given you information about the world that you can make a decision on. Yeah. And I think the same LLMs need that same service effectively. And so what is that context? It's a prompt, but you may not need a complicated data pipeline to say, here is what the user's ticket said. What should I respond to? Right?
Yeah.
But you may also not get the type of performance from the LLM that the best performance that you could get. Compare that to, here's what the users complained to us about, or here's what their ticket said. And here's what they said last time, and here's how many tickets they've submitted in the past 3 days, and here's when they signed up, and this is the most common way they use our platform and stuff like that. And so we think about it as we can help the context that you pass into the model, so the prompt, be highly enriched with relevant information about your business, the product, the user, the specific transaction, stuff like that. And it's basically all the same data supply chain that the feature infrastructure powers. You're just kind of injecting that data rather than as a kind of structured feature vector into ML model, as kind of you're kind of instantiating it as a snippet of prompt macro effectively into the prompt. And we think that's kind of the how the context powers the LLM in the future. Yep. But I think one of the kind of interesting things that I've reflected on a lot is, I think this is a really interesting question. One of the core values of feature infrastructure, one of the key requirements that it solves, is this online offline thing. And because you want to have all this data such that you can train your model. And in the LLM world, you're not training model, usually.
Not exactly. Yeah. Right.
So So what do you need to have the tooling to support that type of that requirement if you're just building LLMs? And what we learned after talking to a bunch of people is that while you may not be training a model, when people are building these LLM applications, they're still going through an offline development workflow that requires
eval,
exploration, prototyping, and eval. And so they might say, hey, which prompt works better? Or which set of signals works better? I want to backfill these, I want to try it on these 1,000 historical examples and score them and see which one I like better. And basically that's what the feature store does. That's what the feature platform is for. So we see like a lot of opportunity there as well to make really crisp user experiences, user workflows for that.
That's awesome. That's fantastic.
Yes. I didn't even think about that. Those examples are perfect. Yeah, that makes a ton of sense. And it seems like that there's a lot of surface area to cover with like the abilities that the feature store has. And right now, as you both know, RAGs are all the rage. And so it's like, this is in a way, it's a RAG, but it's not your typical like, hey, grab a vector database and throw it at the LLM. And Josh, I know you got strong thoughts on vector databases, which...
Yeah, what do you think about vector databases, Josh?
I
want to hear your take on it.
I feel like I'm being set up right now. This is my
punishment. You've got a lot of spicy takes, so I want to...
No, this is my punishment for being 55 minutes late for the podcast, isn't it? Okay.
Exactly.
I guess like I don't quite get it. I guess it's kind of like, why exactly do I need a dedicated vector database as opposed to PG vector or all of the good stuff in the Lucene, Elasticsearch, et cetera, ecosystem? Like, I'm just really sort of thrown here. Has everyone kind of lost their minds? I guess like I don't quite get it. That's maybe the nicest way to say is that I am a dumb person and I don't understand it. I just don't get it.
My guess on my take on vector databases is that there's going to be there's the same people are going to have the same kind of use case, a very popular set of use cases. Give me something similar to this other thing.
Yeah,
it's basically what they help you with. And for the vast majority of use cases, most databases that have implemented a vector similarity in retrieval interface are going to be able to support those. But I do think that there's, if you're a high scale company, you need it to be super real time, you have specific requirements, then it may justify having a specialized solution. But I think you'll be in a situation where that will be the specialized solution. And for most people, you can just use whatever your normal database is with, a vector retrieval interface, and that should be kind of fine. So that's kind of what my guess is where things are going. But there's also, just don't discount the kind of like the workflow around it too. So I think like a lot of vector databases are building really nice APIs that make sense to ML engineers. Yeah. They're saying, this is my embedding, just figure it out. And I want to use this algorithm and it makes it really easy to retrieve it. Or they're saying, here's my new piece of data, update my embedding. And that's like some other stuff that's kind of handled in there that might make the workflows nicer, easier to adopt, so faster to get started and more sticky longer term. So I'm not sold either way, but I do suspect that like a lot of the core retrieval stuff will just be able to be reused across, many solutions will be able to support common use cases.
I just feel like that kind of thing is like something that there will be a Supabase style company that comes and does this, on top of Postgres, and it'll have like this awesome feature. It'll have two really critical features. One is it'll have a great workflow for machine learning engineers doing like vector type operations. Two, it won't lose my data. It won't lose it. It will keep the data. This is one of those things that's kind of like a baseline, very low on the Maslow's hierarchy of needs of data stores.
Yeah. Are you worried about reliability in vector databases? Is that what you're referring to?
I worry about reliability all the time, man. I worked at Slack, for God's sake. Anything that can break is going to break as far as I'm concerned, right? Even S3, like what the hell happened yesterday? Like we lost West 2 and East 1 at the same time, right? You talk about like times you're happy to be retired. Oh my God, that was amazing. Right? Like everything breaks. Except, and so like the S3s and the Postgres's and like all, it's old safe, boring technology that doesn't lose data. It's like my warm safety blanket, man. I'm an old fuddy. Like, look at this neck beard, right? Look at that. That's just like, this is just how I roll. This is who I am.
You've got your old friends that you return to, and
I do.
And you've formed those relationships over many hours on the keyboard.
It is entirely possible that 22-year-old Josh Wills would be all about vector databases and be like, oh, clearly I need to write my own vector database. That's the obvious solution to this. But 44-year-old Josh doesn't. I don't do that shit anymore. That's just not, like, absolutely not. Yeah. Anyway.
Well, one thing that we've seen be kind of like an overlap with our world is this kind of core workflow where someone goes, hey, I want to retrieve, so I want to have good recommendations. So what I want to do is retrieve similar objects. I want to get a set of candidates effectively from my vector database. And the vector database becomes a candidate generator. That's how we think about it.
Yep.
And then use a feature store to enrich those objects. So provide a whole bunch, like 1,000 features for each one of them, such that I can then score them and produce a much higher fidelity understanding prediction of, what's the PCTR? Is someone going to click this ad or this object or whatever, this item, and then rank it by that. And I think we've seen a lot of compatibility in both systems, and I think there's still a lot of opportunity in joining those workflows together in some nice way, and that's a thing that we're going to be investing in the future as well.
Spent a lot of time working on that problem on Slack, so I would love to hear what you're working on there. That I did, it was all of it. Candidate generation, re-ranking off of your feature store, absolutely, 100%. Yeah.
Well, as you're talking about workflows, one thing that interests me is this idea of like templates. And it seems like there are very clear problems that people are trying to solve for. Have you thought about templatizing stuff, Mike? Or
we thought about templatizing stuff there's so many different so we've thought about templatizing things and we've shied away from it. So we've tried to stay a little bit lower level. We would like to. There's a lot of cool things that we can think about right now. For example, what if we just had like a common set of fraud features or common set of fraud feature definitions that you could write onto your own data, or a common set of third-party features that are just available in Tecton that you could use, or like a prototype fraud application and recommender application that's kind of built on. So all of these different things. But we find that like it's kind of unlikely for any of those to be completely just copy paste and just like stamp into my own world. And those and so I like the idea of that, but I just haven't gotten to the point where I think like that's actually the thing that's going to unlock something for our customers. Our customers come to us and they're like, look, we've got this hard problem. We've been trying to solve it in our own world, but we don't have enough people, or we don't know how to do it in real time or whatever it is. Yeah. And so it comes down to like can this technically happen? And then we enable them rather than like, we don't have enough time to like write the features. Writing the features is the easy part. And I think what you're referring to is kind of the templatization of the workflows across different pieces of tooling, like the vector database and the feature store thing I was just referring to. And maybe that's a more appropriate domain for it, but we haven't gotten there yet.
It still feels like we don't have it right yet to me. I don't feel like we have we're still kind of groping around trying to find the right architecture, the right pattern, the right abstractions and stuff like that. And a lot of people are trying right now, which is great. But anyway, I don't see it yet.
Yeah, and I definitely feel like it's taken time, but I feel like we've gotten to the right place in the feature infrastructure, like the feature store, feature platform stuff.
Yeah.
The concepts are solid, and so we feel like we've converged there. And so now we're taking on exactly what you're saying. What are the abstractions for the next set of workflows, next set of use cases that people have? And it's an open question, so we're learning from the community just as much as anybody else.
Dude, well, Mike, I said this to Kevin, 3 years ago when he came on one of the first podcasts that we did, and Kevin, your co-founder, the thing that I would love to see I don't think you've implemented it yet, but some kind of gamification on the amount of money that features cost or the amount of money that features will save, or something like who has created the most features, and then they get badges within Tecton or something. It's like you can see like, oh, this person's been working hard. Look they created thousands of features.
Yeah, I think so it's a cool idea, and it's the kind of thing that requires some I'm not sure exactly what it is, but we had something like that at Google. So at Google, you had this one big problem that you're trying to solve, which is like ads click-through rate. and trying to make a better prediction. And then you have all these different teams that are like creating better features and they're running experiments. Does this feature make us more accurate or not? And I think like if you get to, for your business, if you have the AI problem that is so valuable that it justifies having different teams constantly working independently to compete against each other, to nudge things up by like a handful of %. And there's not an obvious bottleneck, but you're kind of like, what do we do now? Let's get creative. Then that's kind of like a fertile ground for that kind of competitive dynamic. But I think most of the teams realistically are like, hey, how do we like get this thing in production? And so a lot of people are just kind of getting the first thing going and trying to go from 50% accuracy to 80% accuracy instead of 99 to 99.2. Hello.
We've got intruders.
Basically,
the time they cut me off. They said I'm gonna go back on vacation mode.
I love it.
All right, guys. Well, thanks so much. This was a good convo.
Yeah,
I love it.
Thank you so much, y'all. Thank you.
I appreciate this. I'll see y'all later. Thank you.
I'm Emmanuel Mason, machine learning engineer at Stripe and author of Building Machine Learning Powered Applications. And if you don't want your machine learning models to explode, well, you should subscribe to this podcast.